Good evening, ladies and gentlemen, esteemed guests, and conference scholarly delegates. A heartfelt welcome to you all to the online ATAL Faculty Development Program on Green Energy Solutions organized by AICTE Training and Learning Academy and co-organized by Department of Mechanical Engineering, College of Engineering, Muttathala. I am Shalu MS, your host for the day. We are gathered here to exchange ideas and open discussion with the aim of building a sustainable carbon neutral world. It is indeed a golden opportunity for each one of us to enrich and enlighten ourselves. Without further ado, let's dive into our promising schedule. I welcome Dr. Satish Kumar M., Coordinator, Faculty Development Program, and Assistant Professor for Mechanical Engineering, College of Engineering, Muttathala.
We are delighted to welcome participants from various institutions across the country who shares a common passion for advancing sustainability and green challenge technologies. Your presence and active encouragement will definitely enrich this program. As we begin this program, I invite all of you to make the most of the sessions, interactions, and resources that this FDP has to offer. Together, let us contribute towards building a sustainable, energy efficient, and carbon neutral future. With these words, I once again welcome all of you.
I hope this would enlighten the participants with the various aspects of green energy and will be highly beneficial by way of providing an excellent learning opportunity. I wish all the success for the program.
It is my privilege to present the outline of the ATAL online 6-day faculty development program on green energy solution, building a sustainable carbon neutral world. The FDP spans 6 days from January 13th to January 18th, 2025 and features a rich lineup of sessions conducted by eminent experts from academia and industry. Together, let us build a foundation for a cleaner, greener, and more sustainable world. Thank you. I look forward to fruitful and enriching faculty development program.
Myself, Arun, Assistant Professor, Mechanical Engineering Department, College of Engineering, Muttathala. Now we move on to the first session handled by our Chief Guest, Professor Dr. P.V. Aravind, who is the Professor and Chair of Energy Conversion, University of Groningen. He is leading the research activities related to the development of fuel cell systems with special focus on gasifier SOFC, solid oxide fuel cells integrated systems. And he is guiding several PhD students and also postdoctoral researchers. He has held various positions such as Director of Hydrogen Economy, Wubbo Ockels School, Groningen University. He was the lead in nature-based negative emissions program of Technological University of Netherlands. He was also the Hydrogen Advisor, Agency for New and Renewable Energy Research and Technology, ANERT, under Government of Kerala. He was also the advisor for Center of Excellence in Energy and Environment, Kannur Government Engineering College. I once again invite Dr. P.V. Aravind sir for the first session on the topic, Building the Hydrogen Economy, Pathways to a Clean Energy Future. Over to you, sir.
Distinguished academics, principal of the college, dear all, a very good evening. And my many thanks to the organizers of this event for giving me the opportunity to be here. It's an honor. And but also I'm very happy that this event is organized by Muttathala Engineering College, which has a history of hydrogen events, especially the Hydrogen Hackathon organized, India-Netherlands Hydrogen Hackathon organized a couple of months ago, where the college team came out as the winners. So I also would like to congratulate once again to the team and also thank and congratulate the college again for the continued efforts. So we saw the the performance with the hackathon, but it's very clear that it's not stopping there. So, well, it's nice to see that there are follow-up events like this. So the Hydrogen Hackathon was organized with participants from Netherlands and India. And that's because Netherlands has a very serious hydrogen program. And same is the case with India. India is also seriously looking at hydrogen opportunities, and Kerala is also playing an important role. And this is very, very clear that it's important to cooperate. It's important to learn from each other. And well, coming from Groningen University, it's also an important topic for us, because Groningen Valley of Europe, and the first, probably the Hydrogen Valley of the year for the year 2022 for Europe, and where there's a very significant transition taking place. So the largest, it used to be the largest natural gas field of Europe. And in Groningen field, at least, natural gas production is completely stopped because of local environmental problems. And hydrogen is probably being looked as an alternative. And so if it is possible to repurpose the natural gas facilities to store and transport hydrogen, this also gives an opportunity for the economy there to continue. But hydrogen is also a carbon-free fuel. So we know that if you are looking at carbon neutrality, so that this topic is the FDP program is about, it's about carbon neutrality. And if you look at the future, we know that electricity and electric grids are becoming more and more important. So we have more and more electric cars. We have many things getting electrified, but it's also very clear that we will need a fuel because of long-term storage, because of heat requirements, because of multiple reasons. We also need a fuel, and we also need to look at probably a carbon-free fuel for the future. And if you look at the climate change and its effect, we are all suffering, or many places people are suffering. And we know that what's going on in the US now, and what happened even in the US a couple of months ago with the flooding, but also not only in the US, but also many places, and Kerala, the floods, the landslides. So climate change is something to be taken seriously, and solutions are to be found out. And we all need to work together and learn from each other. So we are also so hydrogen is a carbon-free fuel, but also there are other fueling options, right? Ammonia is also such a fuel. There are also other fuels such as methanol, ethanol, etc. But there is carbon is coming from captured CO2 from atmospheric air. They might also act as sort of carbon neutral fuels, depending upon how the process is organized. But still, hydrogen and ammonia probably are really carbon-free fuels. And it's important to look for carbon-free fuels for the future, especially if you look at a carbon neutral world. But also there are other hydrogen opportunities. For example, hydrogen also could be negative emissions hydrogen in many cases. So what are negative emission technologies? The technologies used for taking out CO2 from atmospheric air and storing the carbon somewhere. And bioenergy technologies with carbon capture are also considered as one of the low-hanging fruits here. And if you really look at biomass, it's carbon and hydrogen plus whatever. And hydrogen could be used as a fuel. And if you store the carbon somewhere, we also can get negative emissions fuel. And so a hydrogen, when we use, so the hydrogen source, when we use, we could also achieve negative emissions at the same time, meaning we can actually store carbon. So, which means if you look at carbon neutrality for the future, so it's important to replace fossil fuel-based systems and devices with renewable energy as much as possible, but we might still find some of these sectors difficult to change, meaning we will need to do something else. And one approach is negative emissions, storing, taking out CO2 from atmospheric air and store it somewhere. So it's in 2018, Nature wrote an editorial about its importance. Then universities, MIT and Stanford, wrote together a position paper on how to achieve negative emissions at gigaton scale, etc., etc. And if you look at such programs, then again, hydrogen could play a role. And we are also happy that we are actually involved in such initiatives from University of Groningen, but also in India. So we work together on a carbon neutrality program. Wayanad carbon neutrality program, especially coffee-based, is very much supported by several universities, including University of Groningen, University of Delft, IITs from India, and also some of the engineering colleges, and also the research institutes, agriculture university, etc. So there are opportunities to work together. So here what we do, if you look at, say, coffee program, and what's the, so how carbon neutrality could be connected to a coffee program, it's quite an interesting story. So world over, coffee price is increasing. This could be also because of climate change and its effects, because temperature change might seriously affect coffee production in many places. That's happening in some of the major coffee producing countries, and the coffee price is shooting up. But the coffee in India is primarily shade coffee or agroforestry coffee, where there are a lot more trees in the coffee plantations. These trees might be helping probably to moderate the temperature change a bit, etc. But also, agroforestry is one way to store more carbon. And so coffee farms in India, in Wayanad and in South Karnataka, are primarily shade coffee farms or agroforestry coffee farms. And the coffee price is going up. So it's important to produce quality coffee to make sure that the farming community benefit most from that. So if you plant more trees, if you increase soil carbon, and if you use the extra biomass coming from, so if you have agroforestry coffee, the biomass production is much higher. And if you use this biomass for bioenergy production, say including biohydrogen, and take out a part of the carbon and store it maybe in soil for soil amendment, you could actually really think of carbon sequestration in coffee farms. To start with, also could be simple technologies. You could actually simply think of biogas production in the slurry content of carbon for soil amendment. And then bring in engineering and technologies for various aspects, from remote sensing to make sure that these trees are monitored or soil carbon is measured properly to manage the farms, fuel energy technologies, bioenergy, pyrolysis, biohydrogen, all could play a role. And bringing all these technologies together, it might be possible to achieve carbon neutrality while increasing farmers' income. So carbon neutrality or achieving carbon neutrality need not be a burden. It also could create wealth. And if we can work together to find such ways, I think it is going to be beneficial for all the countries across the globe. There are such opportunities and such events, and these events, the interaction opportunities provided by these events might also help the community to prepare and work together. So I congratulate the coordinators for organizing such an event, and thanking once again, and I thank the organizers once again for inviting me, and my very best wishes.
Thank you, Aravind sir, for enlightening speech with that cutting-edge knowledge on the corresponding topic.
Thank you very much.
So, can you hear?
Yeah, please.
So, kindly let me know the commercial viability of biological pathways of hydrogen production.
The biological pathways is sort of semi-biological, means biogas production and reforming biogas production to produce hydrogen is also probably one of the easiest ways. But if it's purely biological production, well, I'm not an expert, but I also haven't seen such systems implemented in large scale. If you really look at now, biogas and reforming with biological pathways contributing partly is probably an approach that could be taken up in the very near future. But fully biological hydrogen production, I have not seen such systems commercially working yet. Might come up in the near future. So research is important, but I'm not sure whether it's a solution as of now. Is it a reasonable answer? Maybe.
Yes, sir. Yes, sir.
Thank you.
Sir, can we treat the hydrogen generation from biogas reforming is considered as a green hydrogen?
Well, it doesn't fit into all these definitions, but it should be. And especially if you have reforming and you can also even store CO2, and why it shouldn't be. So even negative emissions hydrogen production is possible with biogas. So it should be considered on par with any green, because if you have a electrolyzer, and if you have the electrolyzer producing hydrogen, solar electricity, this is at best carbon neutral, at best. But still, because you might use some fuel in production spaces, and then it might lead to some emissions. But it's at best it's carbon neutral, and of course blue hydrogen, gray hydrogen, whatever, all have different aspects. But green hydrogen is at least carbon neutral. But biohydrogen could actually be carbon negative, especially if it is biogas and biogas is cracked and carbon is stored. So I believe it should be properly considered as a green hydrogen source. But there is some ambiguity in the papers and describing what green hydrogen is, that I agree with. But it's also for us teachers and academics to discuss and come up with most appropriate most appropriate approaches in classifying the hydrogen produced. Yeah. Okay, I know that might be yeah. Thank you. Maybe this is a confusing answer, but I don't think it's easy to answer in a better way.
Okay, thank you, sir.
Excuse me, sir.
Yeah, sure, please.
Sir, it was not clear why this hydrogen need to be converted to ammonia for transport. Is it is it to increase efficiency, or is there no existing technology to transport hydrogen as such? It is not clear.
Okay, hydrogen is a very small molecule, right? It can actually leak through any small openings, etc. So it's important to engineer these systems properly. So it's possible. That's what companies, many companies believe, and that's why they're investing. But there are also people who actually say, hey, it's going to be a bit difficult than what's being thought of. So other storage methods is important, and hence ammonia. Now, if it is energy-wise more efficient, it's a very difficult question to answer, because we know that our calculations show different possibilities, and we believe that all these chains could actually be designed in more or less comparable, reaching somewhat comparable efficiencies. So efficiencies will not. There might be some difference in the efficiency depending upon the way these systems are engineered, but more or less comparable efficiencies could be achieved. This is our own research drawing, so maybe you will find literature explaining these things differently, but this is what we believe based on detailed calculations. So, but easiness to handle a fuel. That's why people are looking at other fuels, and ammonia is a carbon-free fuel. That's probably the most important reason.
Okay, so thank you, sir.
Yes, sir. We have a Virinjam International Port at Trivandrum.
Yeah.
That is going to commissioning soon. What are the business opportunities for hydrogen production and export or import? and transportation availability, feasibility, and our opportunities?
No, I think it's an interesting question. So if you really look at, say, Australia and Africa are very interesting regions to produce hydrogen. And then you could actually imagine ships actually sailing through the shipping channels connecting these places. And then Virginia is not far away from this such shipping channels, right? 10 nautical miles away, just away from the international shipping channels. And so strategically, it might be an important port for handling hydrogen transport in the future. So that's also noticed probably by, I think if you really look at the newspaper reports, Adani Group is also planning hydrogen facilities in Virginia. So that's partly answering your question, I hope. But also, if you really look at, say, electricity production from South India, combined with shallow seas wind power production from say, Tamil Nadu coast, there are probably opportunities to produce hydrogen and export through Virginia port. So I think Virginia offers opportunities.
Thank you, sir. What are the resources required for the hydrogen production? That I think that is water, clear water. Is it available for that one in Canada?
It's a quite interesting question. It really depends upon water. Probably water availability in India, in Kerala might be sufficient. But also, if you really look at local production and local consumption, if these systems are properly designed, so hydrogen is produced with water splitting, but then this hydrogen is produced as a fuel, and electricity production or energy production is still done with oxidation of hydrogen, which actually results in hydrogen water production. You could actually, what does it mean? You really could have a circular system if you look at water, but engineering it properly is also important. So the question you have raised is very important. I don't know whether there is any quantitative study to give a definitive answer, but I believe it is so. But studies are required. These are all areas where academics could step in and come up with well-prepared thoughts and numbers.
Okay, sir. Okay. Thank you.
So actually, while going for this hydrogen energy, hydrogen being a low energy density fuel, it may lead to a increased, it may demand an increased storage capacity. So while using it as a fuel, how can we tackle such a situation?
Well, that's true. So if you go for in north of Netherlands, it's underground, say, salt caverns. So then it's not a problem. The salt caverns will probably enough volume to store hydrogen. Otherwise, cryogenic hydrogen, so liquid hydrogen storage is also possible. So it's still an evolving story. Your question is very important. We assume that in many cases, the known storage solutions are sufficient. There are doubts about whether those solutions are sufficient for all cases. Hence, people are also looking at fuels such as ammonia. So it's an evolving story for academics to make sure that technology matchmaking is properly done. So good question. Unfortunately, there's no easy answer to that.
And one more thing, it is also highly inflammable. So during this transportation also, possibilities of leaking are also there, right?
That's also true. It's also true, but it's also a light. It's not very dense, right? So it can also just, so if you have a flame, it might be a vertical flame, not spreading around. Other fuels might cause actually flames spreading around. So it's all about also engineering these systems. Imagine that a car where you have the hydrogen storage at really one end and you have a flame and it just goes vertically above. So when compared to a flame that's really spreading across a car, it might actually be even safer. Okay, I'm not saying that hydrogen is safer or whatsoever, but it's engineering these systems. There are opportunities and they should be looked into and they should be developed properly. And that's also the responsibility of us engineers.
And also there are two choices for this hydrogen production, like blue hydrogen is there, green hydrogen will be there. So which will be more feasible and economical option, blue hydrogen or green hydrogen?
in the very long run, green hydrogen should be reasonably cheap. That's expected. So that's because that we have seen from these numbers. If you have close to 50 kilowatt hours, you might be able to produce 1 kilogram of hydrogen. And if you have 2 cents per kilowatt hour, it's $1 per kilogram from energy cost. Maybe to that at 30-40% for the investment cost. So maybe $1.5. So there is a serious opportunity that renewable hydrogen is cheap enough in the future. Now, as of now, may not be the case. So local and so case-specific studies are really required. Techno-economics, say system studies, thermodynamic studies-based system studies, and combined with techno-economics, probably all such studies are required. Such studies are required to make appropriate decisions when investment, say appropriate technology choices are made, when investment decisions are to be taken. So no easy answer. It's all going to be, say, case-specific solutions to be developed. And, well, it's an opportunity as well.
Thank you, sir. It was a insightful session.
Thank you. So I think it's 8 o'clock. If there are no more questions, thanks a lot. If there is any last question, I'll be happy to answer.
Thank you, sir, for a wonderful session on giving the relevance of renewable energy requirements, research requirements for our students, and also making aware as faculties of the various possibilities of hydrogen energy research. And in the future, we can see many students going abroad or coming under your leadership for doing projects. And I hope the participants were fully benefited from this session. And thank you, participants, for having a wonderful question and answer sessions. Thank you, sir, once again for the session.
Thank you, sir.
Thank you. Okay then, thank you. Bye-bye.
Thank you, sir. Thank you.
And best wishes with the remaining sessions. Bye-bye.